those regular functions, the base was the variable. In an exponential function, the variable is in the exponent. So we're looking at things like 3 to the x, 5 to the x plus 3, negative 2 to the x minus 1. Something with a variable in the exponent. So first of all, we're just going to write down that definition, the exponential function, and then we are going to talk a little bit about what their graphs look like. So an exponential function is a function of the form f of x equals a to the x. A is a positive real number other than 1. Okay, so the base, we're always talking about positive bases, exponents bigger than 1, or other than 1, I guess I should say. We can have a negative exponent. So let's just evaluate a couple exponential functions. So my function is f of x equals 4 to the x power. So if I want f of negative 2, we plug that in, and that gives me 4 to the negative 2 power. Now we've worked with exponents before. What does a negative exponent do? So that's 1 over 4 squared, which is 160. Okay, these basic properties, I expect you to be able to use this. You do not need to pick up your calculator to do 4 to the negative 2 power. You can do that. Just think about what the negative does. You can square that, no problem. Okay, B, f of 5. What does that mean? 4 to the 5th. Now that's going to be a bigger number. You know, 4 squared would be 16, times 4 would be 64. Times 4 would be 256, times 4, 1024. All right, what if I put in a 2/3? So 4 to the 2/3, what does that mean? How do you deal with those rational exponents? The cube root of 4 squared. What is 4 squared? Okay, cube root of 16. So let's break up 16. What perfect cube goes into that? So we get 2 times the cube root of 2. Broke 16 up into 8 times 2. The cube root of 8 is positive 2. You guys remember doing these things before? Okay, D. F of 2.15. So if I say 4 to the 2.15 power, can we evaluate that one in our heads? No. The rest of these we could work through and simplify. Decimals, we can't so much. So go ahead and type that one in your calculator. 4 to the 2.15. And what do you get?
8.6. Oh, I meant to know.
6.7.
Say that again?
19.7.
And that's approximately, right? You had to round that. It wasn't a pretty answer. Okay, so we can evaluate any exponent. The nice ones, we prefer the whole number exponents. Just as a review, what's anything to the first power?
0? No, it's not.
It's cell. What's anything to the 0 power? 1. Okay. Okay, so on this handout, what do you notice when you put in the points -1, 0, and 1?
And then you get a fraction.
Okay, when you put in the negative, we got a fraction. When you put in 0, you got out 1. When you put in 1, you got that number. So the first 3 graphs here are very, very similar. All the points When you do -1, you get 1/2, 1/3, 1/4. Put in 0, you get 1. When you put in 1, you get 2, 3, 4. The graphs all have the exact same shape. They all go through one identical point. Domain of all these, you can put in any x values, so negative infinity to infinity. The range, what kind of y's did you get out? Positive. So our range is just 0 to infinity. Do any of these ever touch the x-axis?
No.
No, that's an asymptote actually. So there is no x-intercept, but they all have the same y-intercept, which is 1. And all of these graphs are increasing or decreasing? Increasing the entire time. Now in 4 I changed it. I threw a negative in front. What did that do to the graph?
Flipped it over the x-axis.
Flipped it over the x-axis. When you're applying that negative, you're going to do 5 to whatever power and then put a negative on your final answer. So we see our graph looks like this. Domain is still everything. Our range is now negative infinity to 0 because it was flipped upside down. There's still no x-intercept. The y-intercept switched from +1 to -1. And this graph is decreasing the whole time. Okay, on the back, how were these problems different?
They're fractions.
The base was a fraction. So how did that fraction affect the shape of the graph?
Turned it backwards.
Right, it essentially flipped it. It's now decreasing the whole time. So all of these have a domain of negative infinity to infinity, still a range of 0 to infinity, still no x-intercept, y-intercept is still 1. The difference is these are decreasing instead of increasing. Notice when you put in the points -1, that flips it, so 1/2 to the -1 is 2, 1/3 to the -1 is 3, 1/4 to the -1 is 4. What happens when I throw a negative in front of this?
Flips it over the x-axis again.
Right. You put that negative in front, then your points are -1, -5, 0, -1, 1, -1/5. It just takes that graph and reflects it across the x-axis. Domain is everything, range is all the negatives, still no x-intercept, y-intercept moves to -1, and this graph is increasing. Okay, so our conclusions. What's the domain on every single one of these? All real numbers, negative infinity to infinity. What's the range?
Negative infinity is 0 or 0 to infinity.
Right, so it's usually 0 to infinity unless, what?
Oh, with negative in there.
If you have a negative in front, then it's negative infinity to 0. Okay? So it's all the positives typically, but if you put a negative in front, it's all the negatives. What's true about the intercepts? What was our x-intercept on all these?
None.
There was none. The y-intercept,
1 or 0.
One or negative.
Negative.
okay, so it's typically 1. When did it change?
Put that negative
If
in.
through negative n, it became -1. Okay, do we have any asymptotes on these graphs?
Yeah.
What kind, horizontal or vertical?
Horizontal.
Horizontal at y equals 0. Okay, when do we have an increasing function?
It's only 0.
When the base was bigger than 1. So when my base was 2, 3, 4. It could even be something like 4/3. If the base is bigger than 1, it's increasing. If that base is less than 1, so like 1/2, 1/3, 3/4, then the graph is decreasing. If you throw a negative in front, that reverses. Okay? All right. Questions about the graphs of these? Okay, so let's, I've already sketched all those. So these are just some characteristics of the graphs. Up to you if you want to write it down. It's kind of what we just summarized. 3 basic points are easy to find. When you put in -1, it's just 1 over your base. When you put in 0, you get out 1. And if you put in 1, you get out your base. So those are 3 easy points to find on the graph. Question. If your base is bigger than 1, it's increasing. If the base is smaller than 1, then it's going to be decreasing. And the x-axis is always a horizontal asymptote. So I'll give you a second if you want to jot down a couple notes there. Just to help yourself on the characteristics of these graphs.